Hello student, now we'll see ADC on 1 or ADCON1. ADCON1 is also control register of ADC. In last lecture I explained that one of the bit from ADC on 1 and 2 bits from ADCON0 will decide the frequency, conversion time and clock frequency. Now we'll see this MSB ADFM is A to D result format select bit. See, we know we are having 10 bit result, 10 bit digital value. We are having two 8 bit register, TRESH and TRESL. So if it is 1, then it show right shifted. That means it will start the store lower 8 bit into TRESL and the upper 2 bits into TRESH. So the 6 bits from TRESH are remain. So in that we used 00. Once again I'll explain. Right shift means it will store the lower bit of data into TRESL and the upper remaining 2 bits are into TRESH. So from 8 bit, 2 bits are occupied in TRESH. So remaining 6 bits are assigned with a 00. This is called as a right shift testified. If it is 0, then if this bit is 0, then it gives the left shift. What is meant by it? So upper 8 bit store into TRESH and the lower 2 bit store into TRESL. So from the 8 bit, 2 bits of upper TRESL will get occupied and the lower will be 00. So it is called as a left shift justified. Then in earlier lecture we have seen the frequency clock conversion. It decided by these bits. This with association with ADCON0 will decide the clock frequency, this combination. Then the remaining 4 bits decide the configuration of the channel. For example, if all are used as a input, then V reference will be equal to VDD. This is VCC and the V reference is connected to this V reference is connected to VCC and minus V reference is connected to the ground. So all the bits are analog. Because 8 channel we are having, so we need channel selection. If I want only one analog input and the rest of the is I'll keep as it is, I'll go with this configuration. One, 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 0. So all are digital, all inputs are digital, only one inputs. This is assigned as a input of analog input. The V reference as it is equal to VCC. This will be VCC minus V reference is connected to ground. Only one input it will take. If I'll use 3 analog channels, so use this configuration. Digital, this analog, AN3 is a V reference. So we have to give some reference voltage from VCC to minimum value. And 1, 2, 3, 4 are analog channels. Analog 4 analog inputs we can interface. So these are the combinations of your analog inputs. So what are the steps we have to take while interfacing any sensor to ADC? First of all, turn on the ADC module with single bit instruction or bit addressable. We use BSF ADCON0 ADON. We know this ADON from ADCON to turn on the ADC conversion. So this is bit set file. This is bit set file. It's set or turn on the ADC ADON. Make the pin of the select ADC channel as a input pin. We use BSF any from the port A we can use. So here only one pin is used as an analog input, where the X will be decided the channel number. Then select voltage reference input channels. We use ADCON0 and ADCON1. We have to configure these two resistors. Then select the conversion speed through this configuration. Wait for the required acquisition time. Activate the start conversion bit, like in earlier I said, if it is 1 then it will start, the process is still going on. If it is 0 then that means the conversion is completed and data is moved to TRESH and ADRSH and ADRESL and ADRESH. Wait for the conversion to complete by pulling the end of conversion bit. We have to manually or in program we have to note down the bit. This go down bit will be 0. After this goes low, read the SCRESL, ADRESL and ADRESH registers to get the digital data, and the process is repeat. Here I have taken one example. I interface one pot or potentiometer on analog input AN0. So what will be the configuration? Here I used clock frequency 64, clock frequency divided by 64. So the conversion time will be fast. So what will be the configuration for this is, here I am using one, zero, 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 zero and 1. This will set afterward. So first we have to configure it as 0, so the value will be 81. We have to take into ADCON 0. Now ADCON 1, ADFM, this is ADCON this is ADCON 1. ADCON 1 select right justified. Right justified means, I'll explain. See, F oscillator is 64. For 64 it is combination of 1 1 0. This from this combination, and this we have to set here. So these two numbers we have to select through ADCON 0, and this 1 bit we have to set from the ADCON1. Then I use write justified. Write justified means the lower 8 bit will store into TRESL and upper 2 bit will be stored into the TRESH. So the rest of the 6 bit will kept as a empty, or will, to avoid a confusion, I'll take a 00. So here is 1. Then only one analog input is selected, AN0. So for that, the channel selection configuration 1110. Now program trace C and trace D both are assigned as output. Either you can interface LED or LCD. So here interface LED, it will show the binary combination. As I rotate potentiometer, it will show the combination in digital form. It is easy to identify. Then trace A bits, I clear this bit. Then ADCON combination we have already seen. This is also CE. Then I start a delay 1. Then I turn on the ADC conversion by go is equal to 1. Then I'll observe the while ADCON bits is equal to 1, that conversion is completed or not. If it is completed, then load the value into port C and port D. Upper bit will be stored into the D and lower will be into the C. So but it continues observing the if it is done is 1 or not. If it is done is 1, then move to port C and port D. Thank you, student.